For this chapter, we demonstrate how cash flows are actually estimated using our old Project S. We will demonstrate the process in the next slide.
The column headers in the table, the A through I, and the row headers 1 through 38, designate cells, which contain the data. For example, the equipment needed for Project S will cost $900, and that number is shown in cell E4 as a negative. The equipment is expected to have a salvage value of $50 at the end of the project's 4-year life. This is shown in cell I-19. The new project will require $100 of working capital. This is shown in cell E5 as a negative number because it is a cost, and then as a positive number in cell I-21 because it is recovered at the end of year 4. The total investment at time 0 is $1,000, which is shown in cell E22. Unit sales of Project S are shown on row 7. They are expected to decline somewhat over the project's 4-year life. The sales price, a constant $10, is shown on row 8. The projected variable cost per unit is given on row 9. It generally increases over time due to expected increases in materials and labor. Sales revenues, which are calculated as units multiplied by price, are given on row 10. Variable cost, equal to units multiplied by VC over unit, or variable cost over unit, are given on row 11. And fixed cost, excluding depreciation, which are a constant $2,000, are shown on row 12. The depreciable basis is the cost of the equipment including any shipping or installation cost, or $900 as shown in cell E4, C24, and C27. The total depreciation over the 4 years equals the cost of the equipment. We calculate the annual cash flows for the project as over the 4 years in column F, G, H, and I, ending with the net cash flows shown on row 22. The numbers in cells E22 through I22 amount to a cash flow timeline, and they are the same numbers used in Chapter 11 for Project S. Since the numbers are the same, the NPV, IRR, MIRR, and payback shown in cell 31 through C34 are the same as those we calculated in Chapter 11.
Now let us talk about the effects of the different depreciation rates, cannibalization, opportunity cost, and sunk cost.
Effect of different depreciation rates. If we replace the accelerated depreciation numbers in Table 12.1 with the constant $225 values that would exist under straight line, the result would be a cash flow timeline on row 22 that has the same total flows. However, in the early years, the cash flows resulting from straight line depreciation would be lower than those now in the table, and the later years' cash flow would show higher numbers. This is because the dollars received earlier have a higher present value than dollars received later. Cannibalization. Project S does not involve any cannibalization effects. Suppose, however, that Project S would reduce the net after-tax cash flows of another division by $50 per year. No other firm would take on this project if our firm turns it down. Opportunity cost. Now suppose the $900 initial cost shown in Table 12.1 was based on the assumption that the project would save money by using some equipment the company now owns, and that equipment would be sold for $100 after taxes if the project is rejected. The $100 is an opportunity cost, and it should be reflected in our calculations. Sunk cost. Now suppose the firm had spent $150 on a marketing study to estimate potential sales. This $150 could not be recovered regardless of whether the project is accepted or rejected. Should the $150 be charged to Project S when determining its NPV for capital budgeting purposes?
The answer is no. We are interested only in incremental cost because the $150 is not an incremental cost but a sunk cost. For replacement projects, we must find cash flow differentials between the new and old projects, and these differentials are the incremental flows that we analyze. We'll evaluate a replacement table in the next slide.
Here we find the cash flows from the operation with the old machine, then find the cash flows with the new machine, and find the differences in the cash flows. This is what we do in parts 1, 2, and 3 of the table. Since there will be an additional expenditure to buy the new machine, that cost is shown in cell E13. However, we can sell the old machine for $400, so that is shown as an inflow in cell E14. The net cash outlay at time 0 is $1,600, as shown in cell E23. The net cash flows based on the old machine are shown on row 11, and those for the new one is on row 23. Then on row 26, we show the differences in the cash flows with and without replacement. These are the incremental cash flows used to find the replacement NPV. When we evaluate the incremental cash flows, we see that the replacement has an NPV of $80.28, so the old machine should be replaced.